actually CERN is dealing with radionuclear research. But it is more than that, because there are lots of physicians, I know some, they're doing very strange experimentation. There are beings from portals coming in and out. It's physicists from the CERN who told me this.
In a stunning revelation causing a scientific stir, a physicist has made an astonishing discovery that might completely change how people understand space, time, and human place in the universe. The report reveals that there appears to be a secret portal deep beneath the complex underground facilities of CERN. This mysterious gateway could lead to dimensions and worlds far beyond what people currently know. Join us as we dive into this physicist claim and uncover the chilling secrets that might be lurking in the shadows beneath CERN. Astrid Stuckelberger's explosive claims. Dr. Astrid Stuckelberger, a seasoned expert in public health who has collaborated with international entities like the World Health Organization, has recently made some startling claims that go well beyond typical scientific debates. She argues that CERN, the European Organization for Nuclear Research, known for its groundbreaking work with the Large Hadron Collider, is not just exploring the fundamental particles of the universe, but is also allegedly engaged in a covert nuclear program. According to Dr. Stuckelberger, this program's details are being kept hidden from the public for reasons that remain unclear. But her revelations take an even more dramatic turn. She suggests that beneath CERN's massive underground facilities in Geneva, Switzerland, lies a secret portal, a kind of gateway to alternate dimensions or realities. Dr. Stuckelberger claims that through this hidden doorway, beings, possibly from other worlds or dimensions, have been coming into our world and leaving it undetected. These allegations have sparked intense discussions and speculation across various online communities, especially among those who believe in concealed scientific experiments and secret government operations. Adding to the interest, Dr. Stuckelberger asserts that several CERN physicists have privately informed her about the existence of not just a few, but at least 17 distinct realms or planes of existence. These realms are said to coexist alongside our reality, accessible only through unknown and potentially dangerous scientific means. She suggests that this knowledge could have profound implications for our understanding of the universe and humanity's place within it. Moreover, Dr. Stuckelberger connects her claims to other controversial topics, like the famous statue of the Hindu deity Shiva, known as the Destroyer, which stands at CERN's headquarters. She suggests this symbol may hint at the organization's true intentions, which she believes go beyond mere scientific research. While CERN officials have dismissed these ideas as conspiracy theories, the secrecy surrounding certain experiments, such as those attempting to create small black holes or explore dark matter, continues to fuel a variety of speculative theories online. These bold claims by Dr. Stuckelberger have only intensified the public's fascination with CERN, leading to ongoing debates about the potential existence of hidden technologies, alternative dimensions, and even extraterrestrial contact. Dr. Astrid Stuckelberger gave an interview with Maria Zed on Zed Media about 2 years ago. This interview, which was widely shared across various platforms, drew significant attention due to the unusual and intriguing subjects she discussed. Among the most surprising revelations, she disclosed that CERN, the European Organization for Nuclear Research, is not just involved in advanced scientific research but is also deeply engaged in radionuclear experiments. She emphasized that many of CERN's physicists are conducting experiments that go beyond conventional science, entering the realm of the extraordinary. One of the most shocking claims Dr. Stuckelberger made was that certain physicists at CERN have informed her about the existence of mysterious entities that supposedly enter and exit through portals during their experiments. These portals, according to the information she received, could potentially be doorways to other dimensions, adding a layer of mystery to the already complex work being done at CERN. Dr. Stuckelberger's statements, while startling, are not entirely isolated. She is part of a growing group of individuals who have raised concerns about the nature of CERN's research. The assumption that CERN might be secretly involved in nuclear activities is rooted in the fact that their work involves high-energy particle collisions. These collisions, which occur in the Large Hadron Collider, simulate conditions similar to those in nuclear reactions, leading some to draw parallels between CERN's work and nuclear technology. However, it is crucial to understand that CERN's research is fundamentally different from nuclear weapons development. The LHC was built to study the fundamental building blocks of the universe, subatomic particles like protons, neutrons, and electrons. The LHC operates at energy levels that are incredibly high, but still not nearly sufficient to cause nuclear explosions or create weaponry. Furthermore, CERN operates under some of the most stringent international regulations in the scientific community. Founded in 1954, CERN is a hub for cutting-edge research in particle physics, with its discoveries often pushing the boundaries of human knowledge. To ensure complete transparency, CERN publicly shares its research findings in open-access scientific journals, allowing scientists and the public alike to scrutinize and build upon its work. The organization's facilities, including the famous Large Hadron Collider, are regularly inspected by international regulatory bodies, such as the International Atomic Energy Agency, to ensure compliance with global safety standards. However, despite these rigorous protocols, Dr. Astrid Stuckelberger, a prominent figure in public health, raises concerns that echo a broader unease within the scientific community. The fear that advanced scientific research could be misused for military or other nefarious purposes. This concern isn't merely speculative. History offers sobering examples, most notably during the 20th century when the groundbreaking scientific discovery of nuclear fission was repurposed to develop nuclear weapons. The creation of these devastating weapons during World War II not only altered the course of history, but also served as proof of the dual-edged nature of scientific progress. The hidden portal at CERN. One of the most interesting parts of Dr. Stuckelberger's claims is the idea that there might be a hidden portal beneath CERN. According to this theory, this portal could let beings travel between different realms, which sounds like something straight out of a science fiction movie. In these films, advanced technology often acts as a gateway to other dimensions or alternate realities. This theory revolves around the Large Hadron Collider, the world's most powerful particle accelerator, located at CERN near Geneva, Switzerland. The LHC's goal is to recreate the conditions of the universe just moments after the Big Bang. By smashing protons together at nearly the speed of light, scientists hope to learn more about the most basic building blocks of the universe. Some scientists assume that the extreme conditions created by these collisions might cause distortions in space-time. These distortions could potentially create microscopic black holes or even wormholes, hypothetical tunnels through space-time that might connect different parts of the universe. Though these ideas might sound like something out of a science fiction novel, they are rooted in genuine scientific theories. For instance, the concept of a wormhole originates from Einstein's theory of general relativity, developed in 1915. This groundbreaking theory explains how massive objects, like stars and black holes, can warp the fabric of space and time, creating a sort of tunnel that might connect distant parts of the universe. Despite the excitement these theories generate, there is currently no solid evidence that CERN's experiments have created or discovered such wormholes. The fascination with CERN has indeed led to a variety of conspiracy theories. Some enthusiasts have speculated that CERN's experiments might be opening portals to other dimensions or even reaching out to extraterrestrial civilizations. For example, in 2015, the collider's restart prompted fears and rumors about catastrophic events, such as black holes swallowing the Earth. These claims, however, were debunked by scientists who reassured the public that the LHC's experiments were well within the safety margins predicted by theoretical physics. Exploring other dimensions is a popular topic in theoretical physics. Theoretical frameworks such as string theory and the multiverse hypothesis delve into these possibilities. String theory suggests that the fundamental particles we observe are not point-like objects, but rather tiny, vibrating strings. It proposes the existence of multiple, additional dimensions beyond the familiar 3 spatial and 1 temporal dimensions we experience. Similarly, the multiverse hypothesis assumes that the universe could be just one of many, each existing in its separate dimension with potentially different physical laws. These ideas are still largely speculative and are an active area of research, not yet proven facts. One fascinating concept is that our universe might have more dimensions than the 3 spatial ones we experience every day. This idea is supported by several advanced theories, like string theory. According to string theory, the smallest particles in the universe are not simple points, but are tiny, vibrating strings, similar to the strings of a musical instrument. To fit these strings into our familiar 3-dimensional world, string theory suggests there are additional dimensions beyond what humans can see. These extra dimensions could be compactified, meaning they are curled up so small that they are invisible to us. String theory isn't just about adding dimensions for the sake of complexity. It offers a potential theory of everything that aims to unify all fundamental forces of nature into a single framework. This includes the 4 known forces: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. If proven, this could revolutionize our understanding of the universe, potentially leading to breakthroughs in physics, cosmology, and even technology. One interesting possibility is the existence of a portal or gateway to these extra dimensions at CERN. If scientists discovered a portal at CERN, it would suggest that the experiments conducted there might have achieved something truly groundbreaking, creating a bridge between our universe and another dimension. CERN is already famous for its role in discovering the Higgs boson, a fundamental particle that gives other particles mass. If a portal were indeed found, it would signify a leap even beyond this landmark discovery. Dr. Stuckelberger's theorem adds even more layers to this fascinating possibility. She suggests that such a portal could allow beings to travel between dimensions, potentially including extraterrestrials or entities from entirely different planes of existence. These beings might not be constrained by the physical laws that govern our universe, such as gravity, electromagnetism, and the theory of relativity. Theories of higher dimensions, like those proposed in string theory, suggest the existence of multiple dimensions beyond our 3-dimensional space, which might interact with each other in ways we cannot yet fully understand. The potential implications of these beings interacting with our world are profound. It raises questions about their intentions. Are they explorers seeking new knowledge, researchers conducting interdimensional studies, or something entirely different? The nature of these entities could range from highly advanced civilizations with technology that could manipulate space-time itself, to more enigmatic forms of life that challenge our current understanding of biology and physics. If it turns out that this portal exists, it could have profound effects on humanity. It might revolutionize our understanding of science, technology, and even our philosophical ideas about life and existence. Discovering such a portal would shake the very foundations of our knowledge about reality. It could mean that CERN's experiments, which are already known for pushing the boundaries of particle physics, have not only opened a gateway to another dimension, but could have introduced unknown entities into our world. If these experiments led to the discovery of a portal, it would be a groundbreaking revelation, comparable to the discovery of the Higgs boson or the theory of relativity. The concept of a portal hints at the possibility of parallel universes or multiverses, which are supported by theories in quantum mechanics and string theory. These theories propose that there could be multiple dimensions beyond our familiar 3 spatial dimensions and 1 time dimensions. The thought of advanced and intelligent beings using this portal for purposes beyond our current comprehension is both thrilling and unnerving. Such beings could possess technology and knowledge far beyond human own, opening up possibilities humans have only dreamed of in science fiction. This scenario invites people to reconsider the human place in the universe and to confront the reality that our universe might be a far more intricate and interconnected web of existence than people have ever imagined. The shocking truth behind the world's largest collider. The idea of a portal beneath CERN hints at an astonishing level of scientific and technological knowledge that could surpass anything humanity has achieved to date. If a portal were found beneath CERN, it could dramatically transform our understanding of physics and open the door to exploring new dimensions or realities beyond our current grasp. CERN's Large Hadron Collider operates at nearly the speed of light and allows scientists to probe the very fabric of the universe, testing theories that could explain phenomena like dark matter and dark energy. The discovery of a portal could enhance our knowledge of these enigmatic aspects of the cosmos. Such a breakthrough might lead to groundbreaking advances in technology, energy, and communication. Imagine harnessing energy from another dimension or discovering new methods of communication that defy our current technological limits. The potential benefits are immense. For instance, new energy sources from a different dimension could revolutionize power generation, offering cleaner and more efficient alternatives to fossil fuels. Similarly, advances in communication could lead to instantaneous, interdimensional interactions, vastly improving global connectivity. However, the risks of discovering a portal are equally significant. If such a portal were misused or weaponized, the consequences could be catastrophic. The potential for beings from another dimension to enter our world raises serious questions about their intentions and the possible impact on our planet. These beings could bring about cultural, social, and even biological disruptions on a scale previously unseen. In theoretical physics, scientists explore the concept of wormholes, hypothetical tunnels in space-time that could connect distant points in the universe. According to general relativity and string theory, wormholes might allow travel between far-flung locations or even different realms. Some researchers assume that if humans could harness such events, humans might establish faster-than-light travel or access to new areas of the universe. Moreover, the study of such an event isn't just theoretical. The LHC itself has been instrumental in confirming the existence of the Higgs boson, a particle that gives mass to other particles. The discovery of a portal would take human scientific knowledge to an entirely new level, intertwining theoretical physics with practical exploration and potentially revolutionizing people's understanding of the universe. In 2012, scientists at CERN were conducting groundbreaking research on the Higgs boson particle, often called the God particle, due to its crucial role in the universe's mass. During this period, an unexpected event occurred. The hypothesis suggests that their experiments may have triggered a disruption in the fabric of space-time itself. This disruption is theorized to have led to the destruction of the universe as people know it, and a shift into a parallel universe. This concept proposes that what people now experience as a human universe is an experimental construct created by an unknown entity, possibly for observing the outcomes of their manipulations. Some researchers argue that this could explain mysterious events, such as the Mandela effect, where large groups of people remember events differently from historical records, and other strange occurrences that defy conventional explanations. Exploring these theories reveals that CERN's research is both groundbreaking and carefully controlled. At CERN, scientists use the Large Hadron Collider. This colossal machine propels particles to nearly the speed of light, about 299,792 kilometers per second, and then collides them with incredible force. These high-energy collisions mimic, on a much smaller scale, the natural cosmic events that occur in the universe, such as the collisions of cosmic rays or the interactions within black holes. The LHC consists of a 27-kilometer ring of superconducting magnets and detectors buried underground near Geneva, Switzerland. It can create temperatures just a fraction above absolute zero, colder than outer space, to achieve the extreme conditions necessary for its experiments. By smashing particles together at such high speeds, researchers can probe the fundamental forces of nature and uncover the mysteries of subatomic particles. CERN's experiments are designed to address profound questions about the universe's origins, such as why it is made up of matter rather than antimatter, and how the fundamental forces interact. Rather than creating new universes, the aim is to recreate conditions that existed just moments after the Big Bang. This helps scientists understand how the universe evolved from these initial conditions to its current state, offering insights into phenomena like dark matter and dark energy, which make up most of the universe, but remain largely mysterious. Now it's time for today's subscriber pick. In the heart of Geneva, beneath the cutting-edge facilities of CERN, an extraordinary discovery was about to shake the foundations of reality. Dr. Eva Martin, a brilliant physicist with a reputation for challenging the norm, stumbled upon an anomaly in the LHC's data. It wasn't just a statistical blip, but a pulsating energy signature that defied all known physics. As she delved deeper, Eva uncovered a hidden chamber buried miles below the collider, a secret space shielded from the world's gaze. Within this chamber, she found an ancient, shimmering portal, its surface rippling like liquid starlight. This was no ordinary scientific find. It was a gateway to dimensions beyond comprehension. The portal began to pulse with otherworldly light, and out of it emerged beings of pure energy, entities whose forms shifted and shimmered as if they were made of the very fabric of the universe. They spoke in a language of harmonics and vibrations that Eva felt rather than heard, conveying thoughts and emotions directly into her mind. Their message was both wondrous and terrifying. They had been observing humanity for eons, fascinated by our quest for knowledge, but the time had come for a cosmic reckoning. The portal was not just a gateway but a bridge connecting worlds, and it was now destabilizing, threatening to unleash unknown forces upon our dimension. Eva faced a monumental choice. She could shut down the portal, risking the loss of potentially game-changing knowledge and contact with these multidimensional beings, or she could find a way to stabilize it and ensure a peaceful exchange of ideas. The fate of both dimensions hung in the balance as she prepared to make her decision. Would the beings' arrival open the door to unimaginable advancements, or would their presence bring catastrophic consequences? Let us have your opinions in the comment below. The universe's deepest mysteries. The topics explored by theoretical physicists often overlap with the questions asked by amateur researchers, despite their vastly different approaches. Both groups are curious about profound concepts like multiple universes, wormholes, and even the possibility that our reality is a sophisticated simulation. While amateur researchers might approach these ideas from various perspectives, true scientists, especially quantum and theoretical physicists, are dedicated to rigorously testing these hypotheses. One of the key players in advancing human understanding of these complex ideas is CERN. CERN is home to the Large Hadron Collider, which is the world's largest and most powerful particle accelerator. The LHC is an engineering marvel, spanning 17 miles in circumference and buried underground. It accelerates protons and other particles to nearly the speed of light before smashing them together, creating conditions similar to those just after the Big Bang. This extraordinary machine allows scientists to probe some of the universe's most elusive secrets. For example, in 2012, the LHC played a crucial role in the discovery of the Higgs boson, a particle that helps explain why other particles have mass. This discovery confirmed a key part of the standard model of particle physics, which describes the fundamental forces and particles that make up our universe. Moreover, the LHC's experiments are not just about confirming existing theories. They are designed to explore new realms of physics. For instance, researchers are investigating the possibility of dark matter, an invisible substance that makes up about 27% of the universe. They are also looking into the nature of antimatter, which is similar to matter, but with opposite charges. By recreating the extreme conditions of the early universe, the LHC helps scientists test theories about the fundamental nature of reality. For instance, experiments at CERN are exploring whether the universe is one of many in a multiverse, or if there are hidden dimensions beyond the 3 spatial dimensions and 1 time dimension that people perceive. These investigations could potentially revolutionize people's understanding of the universe and human place in it. Despite its remarkable achievements, the Large Hadron Collider continues to intrigue scientists and the public alike with its blend of cutting-edge technology and deep scientific mysteries. This extraordinary machine, a pinnacle of modern engineering and physics, is buried in a 27-kilometer ring of superconducting magnets that stretch across the border between France and Switzerland. It's located more than 100 meters underground, in a tunnel that was originally built for the Large Electron-Positron Collider, its predecessor. The Large Hadron Collider's primary role is to propel protons and other particles to speeds just shy of the speed of light, then smash them together with such tremendous energy that it recreates conditions similar to those just moments after the Big Bang. These collisions generate a shower of subatomic debris, which scientists analyze to uncover the fundamental particles and forces that make up the universe. One of the LHC's major achievements was the discovery of the Higgs boson in 2012. This particle, sometimes dubbed the God particle, was crucial in confirming the standard model of particle physics. The standard model is human best theory for explaining the basic building blocks of matter and how they interact. The Higgs boson is linked to the Higgs field, which is thought to give mass to other particles, a concept vital for our understanding of why some particles have mass and others do not. It also plays a pivotal role in investigating other fundamental aspects of physics, such as dark matter and antimatter. For instance, the LHC has conducted experiments aiming to detect dark matter, an elusive substance that makes up about 27% of the universe's mass, but does not emit light or energy detectable by conventional means. Additionally, the LHC has advanced human knowledge of the early universe's conditions by recreating extremely high-energy environments that existed just after the Big Bang. This helps scientists study events like quark-gluon plasma, a state of matter that existed just microseconds after the universe began and is thought to be responsible for the formation of protons and neutrons. The Collider's work has also fueled public fascination and speculative theories. People have pondered the possibilities of parallel universes, with some even speculating that the LHC might create mini black holes. While such concerns are largely theoretical and not supported by experimental evidence, they highlight the LHC's role in sparking both wonder and debate about the universe's deepest mysteries. The LHC's research continues to push the boundaries of science with ongoing experiments aiming to unlock secrets about the universe's origins, its fundamental components, and the forces that govern them. Unlocking the universe's secrets. The Higgs boson, often dubbed the God particle, is a fundamental piece of the universe's puzzle. This elusive particle is responsible for giving mass to other particles, a discovery that filled a crucial gap in our understanding of the universe. Before the Higgs boson's discovery, scientists struggled to explain why some particles have mass while others do not. Its discovery at CERN's Large Hadron Collider in 2012 was a monumental achievement in particle physics, validating the theory proposed by Peter Higgs in the 1960s. Despite this landmark achievement, the LHC continues to explore the universe's deepest mysteries. The Collider's experiments have unveiled a wealth of information, but they also pose new questions. Among the most pressing and enigmatic puzzles are dark matter and dark energy. Together, these two phenomena make up about 95% of the universe's mass and energy content, yet they remain largely invisible and poorly understood. Dark matter is hypothesized to be a type of matter that does not emit, absorb, or reflect light, making it impossible to detect with traditional telescopes. Instead, its presence is inferred through its gravitational effects on visible matter. For instance, dark matter helps explain the rotation speeds of galaxies and the way galaxies move within clusters. Dark energy, a mysterious force, is believed to be responsible for the accelerated expansion of the universe. This event was first discovered in 1998 when astronomers observed distant supernovae and found that the universe was expanding faster than expected. Despite its crucial role in cosmic dynamics, dark energy remains one of the greatest mysteries in modern science. Similarly, dark matter, which makes up about 27% of the universe's mass energy content, is also elusive. It doesn't emit light or energy, making it invisible and detectable only through its gravitational effects. Scientists are keen to uncover its nature because it influences the structure and behavior of galaxies. Researchers are optimistic that high-energy collisions at particle colliders like the Large Hadron Collider might help humans understand these enigmatic components. The collider's intense energy could produce particles that may interact with dark matter or provide clues about dark energy's properties. In addition to exploring dark matter and dark energy, scientists are intrigued by the possibility of extra dimensions. According to theories like string theory, the universe may have more than the familiar 3 spatial dimensions and 1 time dimensions. String theory suggests that these additional dimensions could be compactified or hidden at very small scales beyond our direct perception. The collider, by recreating conditions similar to those just after the Big Bang, might reveal evidence of these extra dimensions. This discovery could address some of the most profound questions in theoretical physics, such as how to unify the fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, into a single cohesive theory known as a theory of everything. The Large Hadron Collider is an incredible scientific instrument that offers a rare and profound look into the universe's earliest moments. By accelerating protons and other particles to nearly the speed of light and smashing them together, the LHC recreates the extreme conditions of the universe just a fraction of a second after the Big Bang. This allows scientists to probe how the universe evolved from a hot, dense state into the vast, complex universe people observe today. This collider operates at energies of up to 13.6 trillion electron volts, far surpassing any previous particle accelerator. By mimicking the conditions of the early universe, the LHC helps researchers understand fundamental processes such as the formation of matter and the behavior of particles at these high energies. Discoveries made at the LHC, like the Higgs boson in 2012, have already expanded our understanding of particle physics and the fundamental forces that shape our universe. The LHC's experiments have led to several speculative theories and public concerns. One enduring fear is that the collider might create a black hole capable of consuming the Earth. While it's true that the LHC can theoretically produce microscopic black holes, these would be incredibly small and short-lived, evaporating almost instantaneously due to Hawking radiation, a theoretical process predicted by physicist Stephen Hawking. The collider's energy levels are far below what would be necessary to create a large, stable black hole that could pose a threat. Another speculative theory is the potential for the LHC to open a portal to another dimension, or produce a strangelet, a hypothetical particle that could convert ordinary matter into a more stable and dense form of matter called strange matter. However, the scientific community considers these scenarios highly unlikely. The collider's design and safety protocols are built to ensure that such theoretical risks remain purely speculative. Theoretical physicists continue to study these ideas, but there is currently no empirical evidence to suggest that these scenarios could occur. What are your thoughts about these physicists' claim that there's a portal hidden beneath CERN, where beings from other dimensions are coming through? Share your thoughts with us in the comments section below.